Good morning students, welcome to LP Savani Riverside School, Daboli Surat. Subject Mathematics, chapter number 5, Arithmetic Progression. Okay, so we begin with introduction. In introduction, first of all we start with arithmetic progression definition. So what is arithmetic progression? Okay, an arithmetic progression is a list of number in which each term is obtained by adding a fixed number to the by preceding term except the first term. Okay, so don't take tension. I just write here one definition. After the definition, if you are applying this definition in the example, you can easily understood how and what this definition want to say. Okay, so let's start with exercise 5.1. In which of the following situations does the list of number involve to make a arithmetic progression and why? So we want to identify that if this problem is arithmetic progression or not, and in this expression how can we say that this is arithmetic progression or not. Okay, so first of all the question is the taxi fare after each kilometer when the fare is rupees 15 for the first kilometer and rupees 8 for the additional kilometer. So taxi fare for first kilometer is 15 rupees as per the question. Okay, then taxi fare for the first 2 kilometers, it is fixed cost for the first kilometer is 15. After 1 kilometer cut, we taxi fare for the second kilometer is 15 plus 8. We added 8 kilometer extra for the another kilometer. Okay, so 15 plus 8 is equal to 23. Let's taxi fare for the first 3 kilometer is equal to 23 plus 8 because first 2 kilometer wages is 23 and after that I add 8 in the 23. So 23 plus 8 is equal to 31. Okay, so taxi fare for the first 3 kilometer is equal to 31. Taxi fare for first 4 kilometer is equal to 31 plus 8 is equal to 39. These are the taxi fare for the first 4 kilometer. Okay, so it is 31 plus 8 is equal to 39. It's clearly an arithmetic progression because every term is 8 more than the preceding. Here you can say that I added 8 in every terms. So this difference said that this is the arithmetic progression. If the difference between two upcoming terms are same, then we can say that that is a arithmetic progression. Okay, so we take another example. The amount of the air present in a cylinder when a vacuum pump removes 1/4 of the air remaining in the cylinder at a time. Okay, so in initial volume of the air is equal to V liter. Okay, so initial volume for the air is equal to V liter. Each torque vacuum pump removes 1/4 of the V volume. So 1 minus 1/4 is equal to 3/4 V. Okay, so in second stroke it removes 1/4 of the V. The initial is V. So first step is V, then next is third fourth of V. Okay, in this way we can write here third step 3V/4 square, 3V/4 cube. In this way this series is continuously running. Okay, so it is clearly that it can be observed that the adjacent term of this series do not have same difference between them. Here you can see that the difference between these two terms and difference between these two terms are not same, because arithmetic projection is said that the difference between two upcoming terms must be same. It is not following this series, so we can see that this is the not arithmetic progression. Okay, so third and fourth, it is your for homework and practice. Okay, so question number 2. In question number 2, write first 4 term of the arithmetic progression when the first term a and the common difference d are given as follows. So in first, so a is equal to 10, d is equal to 10. So a is equal to first term, so a is equal to 10a. Okay, a2 is equal to a1 plus d, so 10 plus 10 is equal to 20. Third term is a3, a2 plus d, so we can see that a2 plus d means 20 plus 10 is equal to 30. Okay, for next term a4 is equal to a3 plus d. a3 is 30 and d is 10, so 30 plus 10 is equal to 40. So a5 is equal to a4 plus d, so a4 is equal to 40 and d is equal to 10, so 40 plus 10 is equal to 50. Okay, therefore series will be 10, 20, 30, 40, etc. In this way we can find out the whole series from the first term and the difference of the two upcoming steps. Okay, these two are given, this first term and the difference between two terms. Let's we take for a is equal to minus 2, d is equal to 0. Here a1 is equal to first term, and second term a2 is equal to a1 plus d. Here a1 is equal to minus 2 and d is equal to 0, so minus 2 plus 0 is equal to minus 2. In this way we can find a2 is equal to minus 2. Then next a3 is equal to a2 plus d. a2 is equal to minus 2 and d is equal to 0, so a3 is equal to minus 2. Then next a4 is equal to a3 plus d, so a3 is equal to minus 2 and d is equal to 0, so a4 is equal to minus 2. Therefore series will be minus 2, minus 2, minus 2 up to infinite. Then next a is equal to 4 and d is equal to minus 3, so a1 is equal to 4, a2 is equal to a1 plus d. It is common for each and every examples. Okay, so a2 is equal to a1 is equal to a1 plus d, a1 is equal to 4 and d is equal to minus 3. 4 minus 3 is equal to 1. a3 is equal to a2 plus d. a2 is 1 and d is equal to minus 3. So minus 3 plus 1 is equal to minus 2. a4 is equal to a3 plus d. So a3 is equal to minus 2 and d is equal to minus 3. So minus 3 plus minus 2 is equal to minus 5. The series will be 4, 1, minus 2, minus 5, etc. Okay. Then next example is in your homework. Let's we take last example. A is equal to minus 1.25, d is equal to minus 0.25. So a1 is equal to minus 1.25. Here a2 is equal to a1 plus d. a1 is minus 1.25 and D is equal to minus 0.25. Please make the summation of these two terms is equal to minus 1.50. Okay. So next A3 is equal to A2 plus D. A2 is equal to minus 1.50 and D is common for each and every example. So D is equal to minus 0.25. So minus 1.50 plus minus 0.25, it gives minus 1.75. So A4 is equal to A3 plus D. A3 is equal to minus 1.75 plus D is equal to minus 0.25. So A4 is equal to minus 1.75 and 0.25, it gives 2.00. In this way we can see that minus 1.25, minus 1.50, minus 1.75, 2.00 up to infinite. Okay, thank you so much.